Yay. Yeah, so welcome to our first Tech Talk in the last, I don't know, 4 years. So we're going to try to start doing these monthly again. And the first one we're doing is on building a low-cost mesh network with LoRA, specifically using the Meshtastic firmware. I've been messing around with this for about the last 6 months, and I think I'm finally in a spot where I can do a presentation on it. So yeah, we'll get started. Feel free to interrupt with questions, and I think we'll see a stream chat if you happen to be watching on YouTube Live, and you can throw questions in there. So yeah. So quick, what we're going to go over, introduction, understanding mesh networks. You can read it, I don't need to read it to you, but we're kind of going to try to cover a little bit of everything. Not going to go too deep, hopefully, although I may get off in the weeds occasionally. Big block of text, doesn't really matter what it says. The details don't matter, but it's Meshtastic. It's open source firmware for mostly ESP32 devices, although it's available on the RP2040 and a few others. It's got GPS messaging abilities as well as text. And I think somebody's also throwing in, there's some open source projects to add positioning. If you have more than 3 fixed nodes, you can do positioning, as well as a BBS style system. And yeah, the main focus at the moment is text messaging locally without any external hardware in a mesh.
I got a question
Yeah.
already. What's the relationship between this, if any, and the Apple AirTag application, which I think leverages on local cell phone, everybody's cell phone in order to
Right.
implement. That's my real question. Is that intended to implement something similar or comparable?
Not really. So that is actually a good segue into the next slide here. So basic network topologies. So what you're talking about is more like a star network. So you have...
Swiss, can you just repeat the question?
Oh, yes. So sorry, question is, how does this compare to Apple AirTags? So Apple AirTags are much lower range. I think they use Bluetooth for the local connection. So your phone is able to pick up the Bluetooth beacon on the AirTag, and then the phone transmits that data over cellular.
But doesn't it effectively create a mesh of all the AirTag subscribers? For example, like if I want to find out where my bike is,
Right.
and it's in San Francisco, we're not getting a Bluetooth connection from my phone to San Francisco.
No, but it's a Bluetooth connection from somebody's phone
Right, they're
to that.
hijacking somebody's phone
Yes.
to send it, I'm not sure where, but through their own connection to Wi-Fi or whatever.
Right.
And they have some way of sending it back to me.
Right.
But it looks like a flat.
That's true, yeah.
I mean, that's kind of what I was wondering is, at some point you can just look at it as a black box.
Right.
The internals of that is this whole forwarding and hijacking people's phones and whatever.
Right.
And I'm just wondering if what you end up here is a similar black box or not.
No, this is very different. So this is more if you had a bunch of AirTags that could talk to each other and then occasionally connected to a phone and sent data out that way. The distances they cover is also much greater. The link on these is, I think the record is 100 and some odd miles.
The AirTag never talks to another AirTag.
No.
Right.
Well, the range of the AirTag is 25,000 miles.
As long as there's internet.
Right.
This is totally...
This is internet free.
Yes.
Okay.
You can add internet if you want to, but internet free. So yeah, which segues to this slide. So basic network topologies, and this is greatly simplified. But you have a star network where you have a lot of devices connecting to a central node and then connecting to the outside world through that. So like cell phones would be a good analogy, or a Wi-Fi network. But you can have hybrid, so you can have a Wi-Fi mesh network where the Wi-Fi access points are able to form a mesh, but then it's a star network to the devices that connect to the routers, or access points, sorry. And then you have a simplex network, which is just basic straight line, 2 devices talking. You can add a third one, but each hop in that is necessary for the network to work. You can't skip a device in it and have it work, more or less. And then you have a mesh network, and the idea of the mesh network is every device in the mesh is able to talk to every other one, and if they're not, it's self-healing, so as long as somebody is able to reach a device, it will find its way through the network. So a couple of quick terms, because I'm throwing these things out there and you may not know. When I say a node, what I mean is a device like this, which is a LoRa radio, uses ISM band, so in the US 915 megahertz, Europe 858, varies by region, but ISM band, low bandwidth, and there's a microcontroller. So they have fully self-contained ones, like this guy, which, oh, I touched something. So it's got keyboard, screen, all run by the microcontroller, so you can actually send and receive messages totally on one device.
It has a range of 120 miles?
Well, it's line of sight, so as far as you can get that line of sight, it'll connect within reason. There's still atmospheric losses. So the current record, I have it in one of these slides, but 100+ miles.
And what's the typical length?
It really depends on your use case.
Let's push questions to the end.
Okay.
Make sure you get through your talk.
Okay. So the current longest one we have is a 10-kilometer link. So, but most of them are 1 to 3 miles around here. So yeah. So you'll have a node. A lot of the nodes, the less expensive ones, are like this, where it will need another device like a cell phone or a computer to connect to, and use your phone with a companion app to actually send and receive the messages, see the GPS data, that kind of thing. So it's an easier way to access the data on here. But like I said, there are self-contained ones. All right, so there's our network definitions. Theory of operation for specifically Meshtastic. I've got my graphic over here. The time's covered up, but that doesn't really matter. So say you have a, yes?
Sorry, is there a way to turn the lights down a little because the contrast is not...
No, sorry. So this is a theoretical mesh of 4 nodes. A, B, and C are all able to directly connect to each other, and D can only connect to C. So you've got 3 nodes in a mesh, and then one kind of a little bit off on its own. And the way Meshtastic handles that is you have node A will send a message, and it'll have a hop limit similar to TCP/IP, where you've got a hop limit. So hop limit of 3, so it'll send this message up to 3 times. That message is able to reach B and C directly. So message is received, and once it's received, there is a quick bit of math to figure out which of the receiving nodes has the worst signal-to-noise ratio. And the worse the signal-to-noise ratio, the faster it will rebroadcast the message. So when it rebroadcasts, the first node will see that and will interpret it as an acknowledgement. And then with that rebroadcast, node D will receive it, and it will rebroadcast it with a decremented hop limit. And yeah, so that's basically the transit of a message. So this is, I think the term's a naive fill or naive broadcast mesh. So it's your original node's just kind of broadcasting in the dark, hoping somebody receives it, and then we'll follow this algorithm until the hop limit reaches 0. This is also specifically a message being broadcast to a channel rather than an individual node. They're handled a little bit differently. So when it's broadcast to a channel, even if you're trying to reach somebody specifically, all you'll see is that there's an acknowledgement from one of the nodes. If you're trying to reach a specific unit, it will actually return an acknowledgement, and you'll see that in the app.
Will node A ever receive an acknowledgement that the message made it to node D?
Not if you're broadcasting to a channel. It just knows that it reached the mesh.
So the hop limit for broadcasting to a channel effectively determines its range due to the number of repeats?
Essentially, yeah.
Okay.
Sorry, yes. What was the question again, so I can repeat it?
So when broadcasting to a channel, the hop limit of the message would effectively
Right.
determine its
So
range.
yeah, right, exactly. So when you broadcast to a channel, the hop limit will set effectively how far it can reach. It also, the reason is not only to set how far it reaches, but to keep messages from continuously bouncing around inside the mesh. So it'll only be rebroadcast so many times before it stops in order to prevent flooding. So use cases for this sort of thing.
Wait, question, sorry. For the encryption,
Yes.
it was not legal to...
I'll cover that. Question on encryption, but that will come up later. So use cases, off-grid communication, say you're in the backcountry, cell phones don't work, you don't want to pay for satellite. This is an easy line of sight way, or even you can quickly deploy a fixed node to relay messages. So if you can get something up in the airways, even if you're hills and stuff between you, it will relay messages. It includes GPS data, and you can get nodes like this one that have a built-in GPS. So it will always send GPS data. You can also program in fixed messages. So there's a couple of buttons on the side. You can press one that says I'm okay, or one that says problem. You can do short messages that way. So you could also use it for remote sensors or actuators. There's actually a farm up the way here that has large water tanks that they have to monitor. And they were sending people out, and it's an hour-and-a-half drive to get to the water tank, check it, turn it on, come back, end of the day, do it again, turn it off. So they're looking at using Meshtastic to actuate that, check the levels, and then you don't have to do any more driving. It's all centrally managed. And a lot cheaper than burning somebody's time. I mean, these nodes are $30 to $100 each, depending on options. Encrypted local messaging. So if for some reason you want to keep your messaging private and off the internet, off cell networks, this is a great way. If you're in, for some reason, a GPS or cellular satellite denied area, this works great. So it does encryption. I forget exactly the encryption. It's AES something something. It does require a PSK, so a pre-shared key. So you have to agree beforehand, and then you can add that channel. It's got...
Based off of MQTT, or is that just a separate one?
No, so as part of the project, they've added in MQTT so that you can link meshes remotely. So say we want to link the Santa Barbara mesh to a mesh in Ventura, and we don't have line of sight, we can do it over MQTT. And that can also be encrypted. Yeah. So getting a bit into the technical stuff. Each message you send is a max of 256 bytes. You can read the details there, but there's some overhead. So the actual usable size is about 237 bytes. So you're not going to be sending photos or audio or video, at least not very quickly. There's, like I said, companion apps for iOS and Android. There's also a web interface, which I'll show off later. There's a Python API, and I think APIs for a couple other languages. I haven't used them, but I just recently saw they exist. and then MQTT kind of plugs into that for forwarding messages around. So max range, the current record is 158 miles. I knew it was in there somewhere.
Does your cell phone have the hardware needed to go on 900 megahertz?
No, so the link is over Bluetooth
Oh, I see.
or web. You can have the nodes connect via Wi-Fi.
The node has specialized 900 megahertz hardware?
Yes, the node itself has a LoRa radio, which is the 915 megahertz or 858. Sorry, I keep forgetting to repeat questions.
The maximum range, that wasn't from node to node, that was a network.
No, so the maximum range is single node to single node. They had a pair of, I think, Yagi or parabolic antennas, one up on a hill, one down in a valley, and yeah. So the max mesh size is determined by the available RAM of each node. So on the lower end, you have about 50 nodes in a single mesh, and then on the higher end, 100. So, if you have a fancier router, it can remember about 100 separate nodes. And I had to ask about this because I couldn't find it in the documentation, but if you go over your max number of nodes that you can store in RAM, the oldest one ages out. So it's not a big problem, it's just how many you can remember at once. The Meshtastic firmware and LoRa, obviously a bit bandwidth constrained in order to cover these long distances and be reliable. So in Meshtastic, you have a number of different network types, and each mesh, you can have multiple meshes of different types depending on use case. So for your local citywide mesh, you can do short fast, which is high bandwidth, quick communication over a shorter area. And then if you're covering long distances, you'll use the much slower but more error correcting long slow, and you can kind of tailor each individual mesh for the use case.
And the mesh needs to be homogeneous?
So the mesh, so each mesh channel needs to be the same. Well, if it's a public mesh, you can just join it and it will configure itself correctly on the radio. So there's a handshake, and so each node will know how to connect to it. For private ones, you'll have to set that up, but and I can show you, there's a QR code for quickly communicating this. So you can set up a mesh, show somebody the QR code, they scan it, and it configures correctly on their device. There's a lot of hardware options that work with Meshtastic, and they're constantly making new ones. Like this all-in-one guy here, I think is about maybe 2 months old, and it's got a Meshtastic firmware already. So very actively developed. The LilyGo are probably, at least from what I've seen, the most popular and least expensive. The station ones are aimed more at amateur radio operators. There is an amateur radio specific mode that disables encryption and allows for higher transmit power and also more transmit time. So the station guys usually go after that. Rack Wireless, they're a US company, and they make some very neat modular hardware. And almost all of them that I've seen use some variation of the Semtech LoRa radio. The microcontroller ESP32s are probably the most popular, just because they're Wi-Fi and Bluetooth. This guy, the Echo, uses an NRF chip, which is Bluetooth only, which is nice because it's low power. It's got a tiny battery, but lasts quite a while.
What's the range of this modem?
So this one specifically, the farthest I've gone is about 10 kilometers. I went up to the K-Tide transmitter and was able to reach the node on the roof here. So yeah, the node's $30 to $100 just for the transmitter and microcontroller. There's another all-in-one solution that's a little bit more than that, but I didn't include it. So yeah, lots of hardware options out there. On your own time, you can go check out this list. I've set up 3 fixed nodes, and this is my build for them. I didn't think to get a picture of it until now, but oh well. Comes to about $150 a node. If you're doing one, if you're building more, you can get that price down a bit. But these guys are totally self-contained, and they'll just sit there and rebroadcast mesh messages 24/7, 365 with the solar panel and battery. So my existing network are these 3 nodes. So there's one somewhere at UCSB, one on the roof here, and then one, it's roughly where it is, up on West Camino Cielo. We've done a little bit of testing out into the channel. Here we go. So the node at UCSB, this is a hypothetical coverage map based on USGS data. So just from UCSB, we can cover out to, I forget what island that is, and then up into the hills, down a little bit into downtown, and north into Gaviota. And then West Camino Cielo looks pretty similar. And there's my list of citations. And the end of that. So now, yeah, so we can go into the demo. So this is through the web browser connected to the node on the roof. So right now it's able to see 2 other networks broadcast, or 2 other nodes broadcasting their GPS data. So there's us there, and the one a little farther up is my other node on West Camino Cielo. The UCSB one, I don't have broadcasting a location. So there's your map view. And over here on, where's my mouse? On the left, we've got our node name. We can see our list of peers. So these are other Meshtastic devices that it's seen in the last, 2 days? So name, model, address, so on. And then messages. So right now it's only on the primary channel and hasn't heard anything. Yes, I can do that. I guess the reason is I didn't set up any of these channels. So even though, this is kind of a neat thing, even though I didn't set up any of the channels, it's still able to relay messages from anything in a mesh that it hears. So kind of a neat, low barrier way to form the mesh. It just will handle it. And then as far as configuration, it's quite a bit. I don't need to go over all this, but you can set the name, you can set your network that it connects to. This one connects to the wireless network. I may eventually set up MQTT, but for now, just an easy way to manage it. You can actually manage other nodes through the mesh, which I'm not going to be able to show here, but can I? So, yeah, so other radios that I have set up my admin channel on, which is encrypted, I can connect to and change their configurations remotely. So I can have one on the roof of a building at UCSB, and I don't have to go up there more or less ever, unless there's something falls off.
So what are we looking at website-wise? What are, meaning, not the browser or the actual thing, but the back end, what are we looking
So this site is being generated by the ESP32 on the node.
ESP3, okay, got it.
So it's generating the site, and this is just another way to interface with it. I could also do it over Bluetooth.
Oh, no, makes
Yeah.
perfect sense. No, it's just on the ESP32.
Yes. So you can adjust your power. Yeah, all the stuff I've gone over can be managed from this interface.
So these devices are constantly listening and they constantly have their radios turned on?
Yes. So, well, maybe not my mobile one. It'll run out of battery. But if I left it plugged in, yes, it would constantly be listening for messages. And if it gets one, it'll rebroadcast it if the hop limit is correct. Or if it's destined for this device, then it'll accept it and acknowledge it. But yes, they are constantly doing their thing.
What's the power draw?
It varies on the ESP32s. I think it was 30 to 50 milliamps kind of range. On the high end, 100 milliamp during transmit with GPS. No, 180 with transmit and GPS. But that's for a fairly short burst. But the nodes I have on the roof are powered by a 5-volt, 1 amp solar panel. And they have a 10,000 milliamp hour battery. And I've had them go a week without solar, and they continue to work.
Is there a limit on the number of channels in any given mesh?
Yes. So each device, I think, is capable of either 4 or 5 channels. So yeah, you can a bit limited on that.
And explain the relationship between channels and device.
So you've got your device. It's able to listen to, 915 plus or minus, 4 or 8 megahertz of bandwidth, and that's chopped up into channels. And this is actually something I'm still wrapping my head around, but there's LoRA channels. So the underlying LoRA communication has its channels, and then on top of that, the Meshtastic has its channels. So, yeah.
But if you had 3 of those in your hand right now,
Right.
and a message came in, all 3 would receive that message.
If they all have the same channel configured. So there's a default channel that they all, if you don't mess with it, they'll all be configured with. And yes, all 3 of them would receive that. So yeah, you can have, say you want to encrypt each channel, you could have 4 or 5 encrypted channels.
And how many channels are there in the spectrum?
So that's LoRa. I don't remember offhand how many channels LoRa has. I think it's 20-ish. Yeah.
If you had a bunch of devices with LoRa radios, how would you contain traffic between them, apart from just encryption?
So if you had a bunch of these and you wanted to contain messages.
So say for instance I made a big remote control power wheels
Sure.
or whatever, and I wanted to send it command controls over LoRa as opposed to relying on Wi-Fi or cell network or whatever.
Right.
Is there a way to transmit across the network, transmit messages across the network with the traffic still getting to their intended recipient?
Yes. So you can have the way to do that would be you have an encrypted channel that the 2 devices have the pre-shared key for, and then you can directly send it to that device, and it will do its best to hop through the mesh to that device.
Okay.
Yeah. So yes, you can do kind of 1-to-1 across the mesh that way. You can also specify a particular device in the mesh to send to. So let's see if I can, in my list of peers. No. Go away. Oh, primary. I know there's a way to do this. Because it's cut off? Oh, okay. Yeah, it's just because it's cut off. So I could send a message to that particular node named Meshtastic DB5E. The DB5E, Meshtastic will automatically name a node based on its LoRa MAC address, similar to a TCP/IP MAC address. So I could directly send a message to this node, and it should receive it. So I know 4180 is the one I have in my hand here. So let's send it a message. So yeah, so that message sent, and it's interesting. It's off to the side. So there should be an icon showing that it was received, but that may be just slightly off my screen here. But on my mobile node here, it popped up saying 0 seconds ago from SBHX test. And then if I open the companion app on my phone, I would see the same thing.
And that has to be encrypted to go to a particular device?
It doesn't have to be encrypted. You can also over the public mesh, but then every other device can also see it.
Right. So it's a party line?
Basically, yes. So yeah, in my app here, I can see I got that message, and if I reply,
Oh, that's an old phrase, yeah. I think everybody here is aged enough to know what a party line is.
huh. Well, of course, when you go to demo something, it never works, but on my end, I replied, and it says that the node received it, but not showing up in the web interface here.
But you
So.
will never know if the node received it unless it's only one hop.
No, so if you send it directly to a device like this, then you will get an acknowledgement back from that device.
So the device coming back has to go across the mesh within the same number of hops
Yeah,
going back, and then you would actually get an acknowledgement.
right.
And so what we're looking here, when you said it's on the ESP32, this is actually the Meshtastic firmware
Yes.
that we're looking at.
Yeah, this is the Meshtastic firmware generating this page.
Got it.
So we're directly connected to that device. Well, we're connected to that device on the roof over
I was gonna
Wi-Fi.
say, somebody spent a lot of time doing web pages for ESP32.
Yeah,
Mine is like a piece of text. You know?
right. Yeah, exactly.
So what's
They
this?
put some real effort into the UI.
So Meshtastic is both a message protocol on top of LoRa, a mesh networking protocol, and a web GUI firmware.
The question was, Meshtastic is a messaging protocol, firmware for the device, and what was the third one?
And a mesh protocol.
And a mesh protocol. So the underlying mesh protocol relies on LoRa. So LoRa has its own messaging system, and this is an extra layer on top of that. So Meshtastic handles that. It handles the web interface or the Bluetooth connection, and then there are separate apps that are able to talk to the API and generate this kind of stuff for the phone app, as well as the other thing.
If I were to generate write my own protocol
Mhm.
generator and just generate Meshtastic net messages, and would these, is there something, would I essentially just need to know the message protocol and then send it out over the wire?
So yeah, if you wanted to not use the whole Meshtastic firmware and kind of inject your own thing that is able to imitate Meshtastic, yeah. So as long as your message meets their requirements, it will go out.
So similar to the header and the message you were showing.
Exactly. And yeah, I didn't want to
And
get
that
too...
gets sent over LoRa mesh.
Yeah, so that gets sent over the mesh, which you underneath uses LoRa, the LoRa communication, which, yeah, is spread spectrum, and if you want to get in the radio stuff, we can do that. But yeah. So we've got these 3 nodes so far. I don't really have any reason to do it or purpose for it. It just kind of sounded like fun. Maybe somebody will use it for local messaging or command and control. Who knows? But the backbone is there. I haven't done a lot of testing to see exactly what it covers, but like I said, a few miles into the channel, I have somebody going to Anacapa next week to see if we can get that to work. And yeah, you know, hopefully people will pick up some nodes and we'll see how far it gets.
And what are your nodes that you have out there? I know they've got the battery, they got the solar cell, but what is the actual node itself?
So the hardware,
Go,
yeah, so I'm using the LilyGo T3 version 3, I think it is.
and with what kind of antenna?
So my fixed nodes, if you look at that Amazon card I had, they are 5 dBi omnidirectional antennas, with the exception of the one on West Camino Cielo, which is a 915 megahertz patch antenna aimed out at the ocean, because it doesn't really make sense to try to broadcast into the mountain.
Is that part list somewhere, like on the website or something?
So the part list will be in the Hackerspace GitHub after this talk. It'll be available there. And I guess I'll post it in the description for the YouTube video when we're done with this.
How do we join the network? If I wanted to get my own devices,
That's a good question. So if you wanted to join the mesh network, if you bought, say, one of these T-Echoes or one of the LilyGos, anything supported by Meshtastic, and flashed the firmware or the pre-flashed firmware, by default has it's called, I think it's called default channel. Let's see, look at my list here. So it's channel 0, but it's configured by default. So once you get it flashed or pulled it out of the box and powered on, as long as you're within range, it will connect to that channel and you can start sending messages.
Now here's a hairy question. Where does LoRa WAN come in?
That's a good question. So yeah, LoRa WAN, obviously also developed by the LoRa consortium. So it's kind of a similar concept, but it is more reliant on fixed nodes that don't move and are high reliability. Whereas Meshtastic, you know, if you have these fixed nodes, great, but it will operate just as well without them. So that's my best answer. I haven't really dived down that rabbit hole yet.
And so if we were going to play a soccer game and connect a node to every soccer player, because they're all running around the field, and so you're getting relative GPS positions there, this would work in Meshtastic theoretically.
Yeah, so yeah, exactly. So if you had a stadium full of people and everybody had a radio and they're milling around doing whatever it is you do in a stadium, yeah, each one, as long as their line of sight, would be able to connect directly to the other, and if not, it would go through the mesh, and yeah, that would work just fine.
Nodes.
Yeah,
As
exactly.
long as you limit it to the 50 or 100.
Well, and even if you went over that 50 or 100 limit, it just means devices are going to drop out of the node DB, which it will still continue to work. You'll get the messages in the public channels. It's just you won't have it saved and direct messaging it. We'll have to wait until they come back into the node DB.
And then adding MQTT in, which then would normally have that forward to some destination point. That works on a channel, works on a device. How does it?
So
If
MQTT,
it's on a channel, you might be, multiple devices all filling the queue,
right.
and then it have to do, a differentiation across messages, or keep rebroadcasting the same message over and over again.
So I think I understand your question. So yeah, MQTT, there's a public MQTT channel you can join your mesh to. So it's per channel, so like you'll have a mesh channel that is MQTT connected, and the other channels may not be on a node.
Given your network here,
Yeah.
on your default channel, is there a connection to an MQTT server that it would then forward the messages to IP?
Not yet.
Not yet.
I may end up doing that with the node here, but as of yet, I haven't connected to anything to MQTT because I haven't really seen a reason to.
But then my confusion is if you have, let's say, a slightly larger net, and maybe it goes back to my original question part on that, is MQTT is at a device level or at a channel level?
So MQTT is at a channel level. So
It might be hit by a bunch of nodes
single
with the same
node.
message constantly. So if I have a mesh and I have several all connected to MQTT, and a message comes in, and like I was saying, you have 3 of those nodes in your hand at the same time, MQTT would end up with 3 messages to go into the queue.
Oh, I see. No. So it's once. So if you have one node that is connected to MQTT and a message is sent into the mesh, it will only send that out to MQTT once.
If
One node is the repeater.
Right.
the one node, okay, got it.
Or maybe gateway.
I guess, yeah, gateway would be a better word. Yeah, generally you wouldn't have a lot of the MQTT devices in a single area. You'd just have the one gateway.
And so there's a configuration in the firmware that says, you're my MQTT.
Yes, so there's a
And is it
checkbox.
running MQTT on the ESP32, or is it a network connected server?
So the node will send devices over the network to an MQTT server, and then that will be sent out to the internet. So
Okay, so a node at some point has either a Wi-Fi or a Bluetooth connection to a standard MQTT server, and then it goes from there.
correct, yeah. So
And so if we wanted to connect Ventura County with Santa Barbara, the easiest would be each one has an MQTT point on both. And so whatever's on our mesh, if it went to MQTT, it could be redirected over the internet and then rebroadcast in Ventura to the other mesh network.
right, exactly. So you'll have your gateway on both sides. Any message sent into the mesh will be sent out the other end, and vice versa.
I suppose you could make your own like star network out of LoRA devices.
Yes, you could certainly
Call it
build.
MQTT.
Yeah,
Yeah.
you could certainly build your own star network.
If the experiment about whether you can pick up like in Anacapa Island, and if it does work, could, as opposed to going through the internet and stuff like that, could we have a base station on the islands that could potentially also talk to a device, a node in Ventura? And
Yeah, so if you,
basically extend the mesh?
yes, so yeah, you could certainly set up an intermediary device between the two meshes, and as long as it's able to connect to both, messages will get forwarded through the whole mesh.
It would act like a repeater.
Yeah, exactly. And there's so there are actually different modes you can put the nodes in, and router or repeater are options. And there, forgot to mention this part. There's also a store and forward option. So the mesh as it currently or generally is a lot like IRC. So you send a message, and if you're not there, you don't get it. There is an option for store and forward where your router node can store X number of messages, and when it sees a node they're intended for online, it'll send them along.
I have a question
That's
from
more
the
like
interwebs.
Discord.
Okay.
So the question from the interwebs is two-part question. How much does a node have to cost? And would this network be suitable for a small battery-powered scientific devices to report their data periodically from their respective field sites?
So yeah, good question. Cost-wise, on the low end, I've seen as low as $17 before shipping, and on the high end, as high as $100. And yeah, you could certainly set up a connection. So these aren't, well, yeah, so like my T-Echo device here, there's a header on the back, and there are in the Meshtastic firmware ways to set up the GPIO so that you can read all the usual serial, I2C, digital, external devices, and then transmit that data over the mesh. So, yes.
Another question from the internet.
Yep.
Do people use this sort of network for low-cost GPS for search and rescue in wilderness areas?
So, is this used for low-cost search and rescue in wilderness areas? That is actually one of the things it was intended for originally. I haven't found any stories of that, but it is certainly well within its capabilities, since you can either broadcast from your phone your GPS position, or if you have a Meshtastic device with a GPS on it, it can do it. So yeah, you can certainly use it to send out location data.
There are a number of farms that are using it for moisture.
Right.
Reading.
Yeah,
So
exactly.
every
So
100 feet or so they have that.
yeah.
But I don't think they're using Meshtastic for handling all that.
I see. Yeah. So LoRa has a lot of this some of this capability under the hood. This is more an abstraction layer to make it more user-friendly.
What devices that you mentioned, are they specific to Meshtastic, or is there generic LoRa devices that you load the Meshtastic firmware on?
That whole list are generic LoRa devices that you can load the Meshtastic firmware onto. But there's several other similar projects, and I'm blanking on names, but abstraction layer on top of LoRa to do mesh networking, and you can load those firmwares on the same devices.
One thing, I just got a device, and it seems like these devices are getting very popular very quickly, and so if they become available, like through LilyGo or Rack or whatever, they're available for like maybe an hour before they're sold out.
Yeah, I've noticed that too.
Yeah.
So
It's an issue.
yeah, this project seems to be picking up steam, or maybe it's just LoRa in general. But yeah, devices are often being sold out, and they'll pop up and then they're gone fairly quickly.
That sounds like an airway congestion.
Yeah, well, yeah, so they kind of account for that. There is a max airtime per device baked into the firmware, unless you're in ham mode, but generally you're not allowed to transmit more than, I think it's 15 or 20% duty cycle in order to prevent that. I think that's FCC rules.
And going back to, I think, slide number 2, you said there was a way of ham doing 915 at a higher power.
Yes. So amateur radio operators are allowed to operate, I think, on most, if not all, ISM bands at higher levels. So yes, you can put it in ham mode.
I would just put a ham up there instead of just a little device.
Right. The only caveat with ham mode is you're not allowed to use encryption. So everything has to be open. Yes.
You mentioned the web page.
Yeah.
That is generated by the LilyGo,
Yeah.
and does it have to be set up to do that, or is it automatic?
So yes, the web page is generated by the ESP32 on the node, and you just have to tell it to connect to a wireless or wired network, and it will do that. So it's already there out of the box.
Right, and is that in the instructions, or?
Yes, if you go to the Meshtastic site, they'll have documentation. In my references, there's a link.
It comes to the point that I can't read the text on the phone.
Right. So yes, doing it from the web page is certainly an option.
Use an iPad.
I've got an iPad, and I can't get my text.
Uh,
It requires 60 to go on the phone.
so yeah, there's your link to the documentation where you can find how to set up the Wi-Fi portion. So yeah. Anything else? Okay.
Kind of
No.
seems like this is like an intermediary in terms of range and usability between 433 megahertz and then just slapping a cell modem onto a device. Is it like, do they have like libraries for RP2040s or Arduino like type stuff?
Yeah, I mean, it is, I guess, kind of between 433 and cell phone a bit, which is what, I mean, several cell phone bands. There's 815 and, no, 8. Anyway, yeah, there's several bands they'll use. So, yes, it's open source. There are builds for the RP2040, a lot of the ESP models, ESP32 models, and the NRF chips. I mean, there are 433 megahertz LoRa radios, I believe, so that may
Because that's what
be
you
an
have to
option.
use those. In fact, you have to be careful to specify, get a 915, because Europe uses the 433.
I thought it was 858 for
Yeah,
Europe.
they use 858,
Well,
and
they
they
use
use 433 and 915 here in the US.
Okay.
One,
But-
I mean, one gives you a longer distance but smaller bandwidth. I don't know if Meshtastic supports that, but that's
Right.
the basic.
But when you order it, you have to specify which frequency you're.
Yeah, when you
915 seems to be winning out all over the place.
when you order, you do have to specify what region you're in, and it will usually say, you know, North America. Makes it a little easier. So yeah, that's.
Solicited message from some random device. What do you do with it?
So yeah, which I occasionally do, just send out random messages to devices that pop up on the mesh.
Scam all over again.
Yeah, I don't know if it's available. Let's see, in the web version, I imagine it must be. Here's my mouse. But I know in the app you can block individual nodes. So if you don't want to hear from them, you can block them, and then you don't have to hear from them. But I don't know how to do that.
And you've set
From
your
here.
app tops to 3 at this point?
I think, yeah, so I think out of the box, the max hops is set to 3.
Can it hop back to its originator?
So could it hop back to its originator? Yeah, I mean, it certainly could, but that's kind of the point of the hop limit, is to prevent that. And I believe in the headers, the overhead, it has, in fact, I know in the header overhead, it has the unit that broadcast it. So if the unit that broadcast it receives the message back, it will ignore it. All right, well, yeah, that's the presentation. Yay. So yeah, join the mesh. It's not that expensive. I don't really know what to do with it, but maybe we can do something neat.
Good for the apocalypse.
Yeah, exactly. And if not, it's there, so. Yeah. Well, thanks everybody for coming. Next month's talk is on
Subspace?
Subspace, which is
Shared memory IPC system in C++.
shared memory IPC system in C++, presented by Dan. And then that's February. So March, Nick is going to be doing one on the Arduino PLCs, programmable logic controllers, and kind of what you can do with them and how to do it. And that's as far out as we have planned now. So if you have a cool project you'd like to present, let me know, and we've got some time available. And yeah, we're going to try to do more community outreach and stuff like this. So check out our site and Facebook and all the other stuff to stay up to date. Yeah. Yay.